Shotman, can you give us the viewers link, Aya? Thank you.
Okay, hello students. Okay, so today I am going to go through regarding electrochemistry and also redox reaction. So I just took your trial papers. Okay, I took SBP 2020 trial papers and also MRSM 2020 trial papers. Okay, paper 1, paper 2 and paper 3. So we are going to discuss the question regarding electrochemistry and also redox reaction. Okay, so if you see, most of the students, they are confused. What is electrochemistry? What is redox reaction? Actually, both of these reactions, they are related. Okay, they are related and you must be able to differentiate them. Okay, so if electrochemistry means, you should know the okay, which starts from K positive to And very well, we know when we are studying about periodic table, group 1 elements are reactive. Okay, they are reactive metals. So group 1 members are here, followed by group 2 and then group 3. At the bottom, if you see copper and silver, that's why you can find pure coir, or you can find silver things made out of silver. Okay, so that shows that these are the metals that is less reactive and they don't undergo much reaction. Okay, so this is ECS. So if you see under the chapter of redox reaction over here, you have to know the reactivity series. Okay, so reactivity series means it shows the reactivity of the metal. Also quite similar to ECS, it's just that you have addition of carbon and hydrogen in it. Okay, so reactivity series starts with potassium, magnesium, aluminium, carbon. Zinc, hydrogen, iron, lead, silver, and the last reference. And another thing, when you want to explain, especially in paper 2, if you want to explain, if you use ECS, okay, especially electrochemistry, you have to explain in terms of electropositivity of metal. which metal is more electropositive than which metal. If the metal is more electropositive, meaning to say the metal is more reactive. Okay, but the correct term to use is that you have to explain in terms of electropositivity. Okay, so for reactivity series, if you see, you can say which metal is more reactive, the other metal. Okay, so you can use the term reactive. Okay, so if you observe over here, going down, the metals are all becoming less reactive. Okay, the top one are all the reactive metals. Okay, these are the things that you should know. Okay, so we look at the question. So I start with SBP paper. Okay, so if you have it yourself or if you have already tried it, that's good. Okay, so I'm going to start with SBP paper. So trial papers are very important. So I assume all of you have completed the trial papers. Okay, so maybe question from here will come out. Okay, so if you look question number 8, SPP 2020 paper 1, so which of the following has the following types of metal in Voltaic cell? Okay, so you have to know what is Voltaic cell. So when I talk about Voltaic cell, you have to understand there are two types of cell. This is actually under the chapter of electrochemistry. Okay, so in electrochemistry, if you see, cell which undergoes cell. Okay, so Voltaic should be able to differentiate between two cells very clearly. Okay, so if you see electrolytic cell, you need to have battery. Okay, and then you use the electrode, and the electrode that you use, an electrode, it is an inert electrode. So inert electrode means it doesn't take part in any of the reaction that happens in the beaker. Okay, so we use inert electrode. Okay, and then if you see chemical cell, okay, chemical cell electrolyte in it, it is connected to galvanometer. Okay, and if you want to measure the difference in the potential value, then you use voltmeter. Okay, usually will be galvanometer, and the electrode used over here is two different types of metal, must be two different types of metal. Okay, and then if you observe, when you use two different types of metal, okay, the metal will take part in the chemical reaction, meaning to say the electrodes are not inert anymore. Okay, because they take part in the chemical reaction. Okay, so one thing that I want to mention over here, if you look at electrolytic cell, you have battery. So if you have battery means the energy changes. Okay, electrical energy changes to chemical energy. Okay, so the chemical reaction that takes part in the beaker is because of the electrical energy. The electrical energy forces the chemical reaction to happen in the solution. Okay, and then if you observe chemical cell, chemical cell is the chemical energy. Okay, the chemical reaction that takes part in the beaker will produce the electrical energy. Okay, so this is one difference. And then you want to identify whether it is a positive terminal or a negative terminal. Okay, in electrolytic cell, you identify based on the battery over here. So the longer one will give you positive terminal, the shorter one is negative terminal. Okay, on the other hand, if you see for chemical cell, you have to look at the ECS. Okay, so ECS you have for cation and also for anion. So electrode over here are usually made out of metal. So if you refer to the ECL, the more reactive metal. Okay, so for example, if you have a zinc over here and copper over here, zinc is more reactive than copper. That makes this electrode negative, and on the right hand side is positive. That's how you determine whether it's positive terminal or negative terminal. Okay, now if you want to define, okay, which one is cathode and which one is anode, do not memorize in electrolytic cell. You memorize that anode is a positive terminal, and in a chemical cell, anode is a negative terminal. Okay, so you have to understand, okay, anode always oxidation. Always undergoes oxidation means there is oxidation. So you see which electrode has loss of electron, that electrode is anode. Okay, so one electrode will lose electron and another electrode will gain electron. So cathode for both electrolytic cell and chemical cell, cathode always undergoes reduction and always gain electron. Okay, so you can find out that cathode always lose electron. Okay, they will lose electron. So the way that you determine whether it's a positive terminal or a negative terminal and telling whether it is anode or cathode is different. Okay. Okay, so back to the question over here. These are some difference between electrolytic cell and also chemical cell. Okay, so which of the following pairs, so Voltac cell means it is a chemical cell, will give the lowest voltmeter reading. Okay, so if you see, it gives the lowest voltmeter reading. That means you have to see their arrangement in the ECS. Okay, so if let's say lowest means lowest voltmeter reading, that means the distance between the metal must be near to each other. Okay, if let's say they have high voltmeter reading, that means the metals are far away from each other. Okay, so you write down your ECS and then you have to compare, okay, the distance. Okay, so if you look at ECS, you start with K and A positive. Okay, Ca2 positive, Mg2 positive, Zn2 positive, Fe2 positive, Sn2 positive, positive, Cu positive. Okay, so there's no silver over here. Okay, magnesium and copper. So if you observe magnesium and copper, they are so far away from each other. So they must have the higher voltmeter reading. Okay, so you shouldn't be A. Zinc and copper. Zinc and copper also quite far with each other. Okay, iron and copper. Iron and copper, and the last one is tin and copper. Okay, so you can see tin and copper, the distance is quite near compared to the rest. So your answer is D. Okay. Okay, question 11. Okay, it shows an apparatus set up to purify silver. Okay, this is an application. Okay, application to electrolysis. Okay, so if you want to purify silver, okay, so you need to have an impure silver, you need to have a pure silver, then you need to have a electrolyte that contains metal ion that need to be purified. Okay, so definitely if the electrode is carbon, this is wrong. Okay, so definitely the answer is not A. Okay, cannot be carbon. Okay, so what you should put, what you supposed to put as an electrode P. Okay, so electrode P, if you see, you have to put in, this is a positive terminal, negative terminal. Okay, so in your electrode P, you're supposed to put in impure, impure silver. Why to put in impure silver? Because when you put it as the at your positive terminal, the electrode will become thinner. Okay, so electrode will become thinner, and then the silver will be deposit. Okay, it will come out from the electrode. So you have to place impure electrode over here, and you have to put in the pure silver over here, pure electrode over here. Why you have to put in the pure electrode at the negative terminal? So that they will gain electron, okay, and then it will form more pure silver metal surrounding it, and the electrode becomes thicker. Okay, so if you look at the options over here, and another one more is the electrolyte. So the electrolyte, if you want to purify silver, you need to have silver in the electrolyte. Okay, so you can put in any salt solution. Okay, you can put in any salt solution, except for you cannot put in AgCl. Why you cannot put in AgCl? Because very well we know AgCl is a insoluble salt. The chapter salt. So it is actually insoluble salt, and if it's insoluble salt, this is non-electrolyte. Okay, this is a non-electrolyte. Okay, so the best that you can use silver nitrate. All nitrate salts are soluble in water. When they are soluble in water, they can be a good electrolyte. Okay, so definitely not nitrate. This one is also wrong. Your answer should be D. Okay, moving on to the next question. Okay, so this one is to investigate a redox reaction. Okay, so the solution in the test tube change color from orange to green. So orange to green, you should know they use QCr2O7. This is the one that will change from orange to green. Okay, when substance Y is added. Okay, so when they change from orange to green, what happens over here? So Cr2O72 minus change to ion, and Cr3 plus is green. Okay, so if you observe over here, reduction is taken place. Okay, so how do you know reduction is taken place? You can calculate the oxidation number of chromium. Okay, how to calculate the oxidation number of chromium? So we look at the left-hand side over here. So 2x plus 7 to positive 6. Okay, so positive 6, if you plus 3 becomes positive 3. Okay, so if you want to define whether a reaction is a reduction or an oxidation reaction, you have 4 methods to identify them. One, in terms of oxygen, whether they gain or they lose oxygen. Second, either they gain or lose hydrogen. Third, you can look at their oxidation number. If their oxidation number reduce, then it is a reduction reaction. If the oxidation number increase, then it is an oxidation reaction. Okay, and then the fourth method, uh, you can see their half equation, whether they gain electron or they lose electron. Oxidation, always lose electron. Reduction, always gain electron. So it undergoes reduction. So if chromate ion undergoes reduction, substance Y must undergo oxidation. So you want to know out of the four options over here, which one undergoes oxidation. Okay, so some students, they memorize. Another way to identify chlorine water. So chlorine water will be in the form of Cl2. Cl2, it will change to become chloride ion. These are the changes that can happen. Okay. So Cl2 becomes Cl minus. This is 0. The oxidation state is 0. Oxidation state for any is 0. And for Cl minus, it is -1. So this is a reduction reaction. In iron 3 chloride, Fe3+ is important. Chloride ion is just a spectator ion. It will change to Fe2+, also reduction. So very clear, you can see Fe3+, 3+ become 2+, oxidation number reduced. Okay, potassium iodide. So in potassium iodide, iodide ion is the one which is important, not potassium. Potassium is just a spectator ion. Okay, so so you can ask me how I can say which one is a spectator ion, and the one that have change in color is the one that is important. The one that doesn't, any ion that doesn't give any change of color, that will be the spectator ion. So I minus will become I2. So -1 becomes 0. Okay, so -1 over here becomes 0. So this is oxidation reaction. So we want oxidation. Acidified potassium manganate solution over here. MnO4 minus becomes Mn over here. Okay, you can find this is also another reduction reaction. Okay, so your answer is C. Okay, look at question number 36. Okay, diagram shows the apparatus set up for displacement reaction. Okay, so you have copper to chloride. So displacement means one metal kick out another metal. Okay, so you have copper to chloride and also magnesium strip. So what happened in this reaction? CuCl2, okay, plus with magnesium. Okay, so if you look at the reactivity series, we know copper is less reactive than magnesium. Okay, so magnesium is not happy in the form of solid, will form a solid metal. Okay, because copper is less reactive. Okay, so look at A. Copper ion is oxidized. So copper, if you see over here, copper is positive 2. Over here, copper is 0. Positive reduction. It is not being oxidized. Okay. B. Copper undergoes reduction. Okay. It's not copper undergo reduction. It's supposed to be copper ion undergoes reduction. Okay. Copper ion is the one that undergoes reduction. So also wrong. C. Magnesium releases electron. So if this is reduction, so oxidation means what? Lose electron. So lose electron and release electron is the same. So your answer should be C. Oxidation number of magnesium decreases. So magnesium on the left hand side, if you see, it is 0. On the right hand side, it is 1. the oxidation number is positive 2. Increases. Okay, look at question 43. So question 43, what is the oxidation number of nitrogen? Okay, in nitrate ion. Okay, so you should know what is nitrate ion. Nitrate ion is NO3 minus. So you perform a simple calculation assuming nitrogen is X plus 3 negative 2 equals to negative 1. So you have to solve this and you will get nitrogen is positive 5. Okay. Next question, 38. Okay. Diagram 38 shows the setup of apparatus for the experiment to construct the reactivity series of metal. Okay, so this is the setup of the apparatus, and then they give you a table over here, table 38, to show the observation when metal PQRS are heated strongly. Okay, so if you observe, you have to look at the keywords over here. Metal P burns quickly. Metal Q burns vigorously. Metal R glows dimly. Okay, metal S glows bright. So when you compare burn and glow, okay, burn means more reactive, less reactive. This is the burn means you have to see they have two types of burning over here. Burns quickly and also burn vigorously. So vigorously should be more reactive than burns quickly. Okay, so this is how you can find out their reactivity. Okay, so which of the following correct ascending order of the metal in reactivity series? Okay, so we try to arrange them ascending order. So ascending order means we have to find out the one which is less reactive. Okay, the one that is less reactive will be R because glows dimly, followed by the next glowing, which is glows brightly. Okay, and then followed by the next one, burns quickly, and the last one, which is the most reactive one, burns vigorously. Okay, so this information is good enough for you to find out the answer. So it should be RSPQA. Okay, question 49. So question 49, if you see, this is a setup of apparatus to investigate transfer of electron at a distance. So electron moves from electrode M, okay, to electrode N through the connecting wire. Okay, so they ask you what is X, solution X and solution W. Okay, so you have to identify where does the oxidation and also reduction happens over here. Okay, so the clue over here is the transfer of electron. So you can see M over here produces electron. That means there is loss of electron over here. And over here, the electron is traveling to electrode N. So there is gain of electron happens over here. So from here, you can conclude this one should be a reduction reaction. Okay, so you can see, we look at X first. Potassium change color. So leave potassium aside. So you look at iodide. So iodide, I minus 0. Increase, the oxidation number increases. So oxidation taken place. Iron sulfate, which one changes color? Iron. So Fe, 3 plus becomes Fe2 plus. Read. Okay, we can check with the next one. Okay, bromine water. Br2 becomes Br minus. Okay, so Br2, if you see the oxidation number is 0, 0 to negative 1 is reduction. So it is wrong. Okay, then maybe we can, so this one is also wrong. So option C, we can look at iron 2 plus. Fe2 plus becomes Fe3 plus. So you can see there is increase in oxidation. So oxidation taken place over here. Look at potassium iodide. Becomes I2. All okay, so one should be oxidation, another one should be reduction. Okay, so moving on to the next question, 42. So this is a setup of apparatus to electroplate an iron spoon. Okay, so this is electroplating. Previously, you have seen purification of metal. That is also application of electrolysis. So this is also application of electrolysis. Okay, so you have your negative terminal and your positive terminal. Positive, this is positive. According to the diagram over here, this is negative. Okay, so after 30 minutes, no change was observed on the iron spoon. Okay, what should be done to get shiny gray layer on top of iron spoon? So you want argentum to be deposit on the iron spoon over here. Okay, so what is actually happening over here? If it's a positive terminal, okay, so in electrolysis, if it's a positive terminal, that means there is a oxidation taken place over here. So it's supposed to be anode. So anode means it will lose electron. So lose electron means iron spoon will become thinner. Okay. And then the negative electron over here, that means in electrolysis, they want to gain electron. So gain electron means it is reduction and it is the cathode. Okay. So what will happen over here when they gain electron? Around. What we supposed to do? We have to change the terminal over here. Negative terminal should be on the spoon. The positive terminal should be on the silver. Okay, so your answer should be C. Interchange the terminal of the dry cell. Okay, question 29. Okay, question 29, if you see, it's a combination. Okay, you can see cell 1 and you can see cell 2. Combination of cell 1 and cell 2, both electrode X and Y are carbon electrode. So you already got the clue over here. X and Y are carbon electrode. So if it's a carbon electrode, it's an inert electrode, and this is supposed to be the electrolytic cell. Electrolysis taken part over here. Cell 2 will be the voltaic chemical cell. Okay, so cell 2 will become the battery for cell 1. Okay, because just now we got see the changes in energy that I mentioned to you. Electrolysis means it is the changes of energy. That means cell 2 will provide electrical energy, and that electrical energy will be used by the voltaic cell. Okay, which is the cell 1. Okay. Sorry, yeah, this one. This is the voltaic cell. This one is the one that will change. This one, chemical energy will become electrical energy. Over here, the electrical energy received from cell 1 will be changed to chemical energy. Okay, so you have to identify the positive terminal and also the negative terminal. Okay, so who is the battery for cell 2? Cell 1. Okay, so how do you determine the positive and the negative terminal? Look at the metal over here. Okay, magnesium and copper, which one is more reactive? Magnesium. Negative terminal, copper less reactive, positive terminal. Okay, so negative terminal, this will be the negative terminal, X over here will be a positive terminal. Okay, so what is the question? Which of the following ions attracted to electrode Y? So electrode Y is a negative terminal. What is the solution? Copper sulfate solution. So if you see the ions in copper sulfate solution are Cu2 plus, have H positive, okay, and you have sulfate ion, and you have OH minus ion. Solution. Okay, so which one will be selectively discharged? Oh, they didn't say which one is selectively discharged. Which of the following ions are attracted? So negative terminal means only positive ion will be attracted. So the answer is A. Okay, so very important, you must identify the terminal correctly, then only you can answer the question. Okay, question 30. Bridge pillars which are exposed to water will rust easily. In order to protect the pillars from rusting, okay, it is usually attached to another metal. Okay, what is another metal that's supposed to be used? Okay, so if you don't want the bridge to rust easily, you need another metal. That means iron. You need another metal which is more reactive than iron. Okay, so you need something which is more reactive than the iron. So you can refer to ECS. Okay, if you look at Fe, Sn2 plus, Pb2 plus. Okay, so you cannot use any of the metal over here. Use any of the metal over here, iron will get rust faster. Okay, so you need to choose something which is more reactive. So copper also cannot. Copper is also at the bottom. Copper cannot. Silver cannot. Tin also cannot. So if you put zinc attached to the bridge pillar, zinc will get rust. Okay, not the Fe2 plus. So this is known as a sacrificial metal. Okay, so B is the answer. Okay, then we move on to SBP paper, section B. Okay, why solid magnesium? Question number 7. Why solid magnesium chloride? Okay, does not, so must read the question carefully. Magnesium chloride does not conduct electricity. This is solid magnesium chloride. Does not conduct electricity. So how you should answer this question? You need to know what is the keyword. So the keyword is you have to use whether there is free moving ion or there is no free moving ion. So 4 marks is given over here. So how are you supposed to explain? So you have to explain for both. You don't explain for solid only and you ignore molten. So explain for both. So you say there are no free moving solid magnesium chloride. Okay, there are free moving ion in molten. Okay, so you write down in a full sentence. This is your keyword. So when they ask about conductivity, means you have to explain in terms of free moving to say why it can conduct electricity. Okay, for in molten state. So you have to say Mg2 plus ions to cathode and chloride ions attracted flows from anode. Anode always lose, it goes from anode to external. Okay, so if they can conduct electricity, then how they can conduct electricity. So 4 marks. Okay, moving on to the next question. You are provided with molten aluminium chloride and concentrated aluminium chloride solution. So there is a difference between molten aluminium chloride. So in molten aluminium chloride, you only have 2 ions, Al3 plus and the chloride ion. Concentrated aluminium chloride solution, you have 4 ion because you have to put into the water and dissolve it. So you have Al3 plus, you have H positive, okay, from water, you have chloride ion, and also you have hydroxide ion. Okay, so since they say concentrated aluminium chloride, you forget about the hydroxide ion over here. Okay, chloride ion and also aluminium and H positive ion. Okay, because concentrated, the ion that is more will predominant. Okay, will be predominant one. So electrolysis process are conducted by using carbon electrode, okay, to obtain aluminium metal and chlorine gas at electrode. So they already decide these are the product that need to be produced at the each electrode. Okay. So they say choose suitable electrolyte to obtain the product. Okay, so now we have to find out. So if it's aluminium chloride, you only have 2 ions. Okay, so definitely one electrode, positive electrode, there will be a chloride ion will be discharged, and at the negative electrode, um, aluminium ion will be discharged. Okay, but if you use concentrated aluminium chloride solution, okay, have the aluminium chloride solution. So at the positive electrode over here, chloride ion will be selectively discharged. At the negative electrode over here, you have 2 ions, Al3 plus and H positive. Okay, so if this one you have to choose according to the electrochemical series. Okay, whether it is concentrated or diluted, it will only affect the anion, not the cation. Okay, so when it affects the anion, chlorine will be selectively discharged over here. Now if you look at the positive ion over here, you have to follow ECS. So when you follow ECS, Al3 plus is up, H positive is at the bottom. So H positive will be selectively discharged. Okay, so this will not be a suitable electrolyte to be used for me to obtain the aluminium metal and chlorine gas. Okay, so the suitable electrolyte will be molten aluminium chloride. Okay. Explain how aluminium and chlorine are formed at each electrode. Okay, so you have to describe at each electrode. Okay, so you have to say the ions. I write down over here. The ion present are Al. Okay, then you explain at the anode. Okay, or you can write down in sentence at anode Cl minus will discharge or selectively discharge. No need to write down selectively also because you only have two ion. Will discharge to form chlorine gas. So your answer must be complete. Okay, so you don't just say chlorine will be discharged. Okay, so you can write down try to give your answer as specific as you can. Okay, and then at the cathode, L3 plus ion will discharge aluminium. Okay, and then that's good enough already because you already explained how. Okay, you already explained how. And then if you observe over here, the next one, write the half equation for the reaction. Okay, so write down anode and also cathode. So what have Al2? Okay, so balance the chlorine where you have to add electron on the right hand side because you want to balance the charge. You have -2 ions, -2, the charge is -2 and on the right hand side is 0. So you have to add another 2 electron. And then at cathode, if you see Al3 plus will come Al. So you have to add the electron on the left hand side to balance. So you have +3 and 0. So add 3 and make it 0. Okay. So for question 1, 2, and 3, you can get 6 marks. Okay. So this one you will get 1 mark. 1, 2, 3, 4, 5, 6. Okay, so each point over here you will get 1 mark. Okay, moving on to the next question. Table 7 shows list of materials, apparatus, and instruction to conduct an experiment to compare two types of cell. Okay, so you have cell A, cell B. So you have sodium sulfate, same concentration of sodium sulfate. You have zinc electrode, carbon electrode. And over here you have magnesium electrode, copper electrode. Okay, so the beaker. Cell A, you have beaker, you have battery. This is something which is different. And then cell B, they use voltmeter. So very clear, this one is the electron to you, they will use inert electron. But sometimes question can come out like this. Okay, one they use carbon electrode and another one more is inert electron. So this is the inert electron. This is the active electron. Okay, so reactive electron. So this electron is going to take part in the chemical reaction. That's it. Okay, and then voltmeter means this is a chemical cell. Okay, so instruction, connect zinc electrode to positive terminal. Okay, so I'll draw for you so that it will be clear. So connect the zinc electrode to positive terminal of the battery, positive. So this will be zinc, this will be carbon. Okay, and carbon electrode to the negative terminal of the battery. You have to draw, then only it will be clear enough. Okay, and the electrolyte used over here is sodium sulfate. Okay, so cell B, this is cell A. Magnesium and copper. Connect copper electrode to positive terminal. Positive terminal of the voltmeter. Okay, so voltmeter. Okay, so magnesium and you have the other one more is copper. So this is positive terminal. Correct. According to what we will also predict, okay, the more reactive metal will be the negative terminal. The more, the less reactive metal will be the positive terminal. Okay, so magnesium is more reactive, negative. Copper is less reactive, positive terminal. Okay, and the solution used over here is also Na2SO4. Okay, now they ask you the type of cell. Okay, uh, the type of cell. So you can actually use table to answer this question. Okay, you need to indicate the type of cell, energy change, half equation, observation. So you can actually draw table. So you can put in cell. Okay, in exam you use table. Okay, so cell. So write down type of cell. Okay. So you cannot draw your table without this cell and type of cell. So you must indicate all this. So if you want to write down in sentence, you write down cell A is a electrolytic cell and cell B is Voltaic cell. Okay, cell B is Voltaic cell. And then the second one, they ask for energy change. Okay, write down full energy change. So electrical energy change to chemical energy because electrolytic. Okay, because of the electric given, the chemical reaction forced to happen. So if you look at B, Voltaic cell is the other way around. Okay, and then the third one is the half equation at the anode and cathode. Okay, so half equation, so anode. So what happens at anode if you look at cell A? Okay, so cell A is actually made out of zinc. The electrode is made out of zinc. Zinc itself will take part in the reaction. So zinc will dissolve. Okay, zinc will produce Zn2 plus 2 electron. Okay, anode undergoes oxidation. Okay, oxidation means lose electron. So can you see lose electron? Okay, the next one is cathode. So what happened at cathode? So cathode, if you see, this is the positive terminal, this is the negative terminal. So at the cathode, if you see reduction, okay, reduction is taken place. Okay, so who will be attracted to the negative electrode over here? Two ions, Na positive and H positive. So So definitely Na, okay, because H positive is at the bottom of ECS. So H positive will become H2. So plus 2 electron over here. Okay, so this will be the half for the cathode. Okay, now you look at cell B. So cell B anode. Okay, which one is anode? So the one that loses electron. Who loses electron? This one loses electron. Okay, and then over here, this will be the, this will be the anode, loses electron. This will be the cathode, gain electron. Okay, so what happens at the anode? Okay, so both of the metals over here are the reactive metals. So the metal will take part in the reaction. So anode, if you observe, Mg will become, okay, and then if you observe at cathode, so cathode, you start with the ion. Okay, what are the ions in the solution over here? Okay, so you have Na positive ion and also H positive ion. Okay, H positive ion, and also you have SO4 2 minus ion and OH minus ion. Okay, so definitely if you see at the cathode, they want to gain electron. Who can gain electron? Na positive and H positive, not the negative electron. Okay, so who will be selectively discharged? Okay, so you refer to the ECS, and H positive will be selectively discharged. So your half equation, okay, will be the half equation for the hydrogen. Okay, so if you have copper solution as an electrolyte over here, then only copper ion will be selectively discharged. The ion is the one that will be discharged at the cathode because they have to gain electron. Okay. Okay, and then the next one is the observation. Number 4 is the observation. Okay, so what you can see in cell A, you can see that zinc is dissolving. Okay, so you can say zinc electrode becomes okay, and then if you see for cell B, magnesium is dissolving, Mg becomes Mg2 plus, so you can say magnesium electrode becomes thinner. Okay, so you cannot mention anything about the color of the electrolyte, okay, because Na2SO4 is colorless solution. Okay, unless if you see copper sulfate, then the color changes. Okay, so in this case, you have to talk about what observation, what you can see, okay, using your 5 senses. So you have given all the points over here. So 1 mark, 2 mark, 3, 4, 5. 5 times 2, you will get 10 marks. Okay, so either table or sentence, the important thing, you should have this. Okay. Okay, now we look at section B, SPP number 8, the next question. So the following chemical equation shows displacement of halogen. So displacement of metal, you also have displacement of halogen. The concept is the same. Okay, the more the reactive metal will displace the less reactive metal. Okay, so based on the chemical equations, state the oxidation number. Okay, so must read the question carefully. What are the things that they ask? First, state the oxidation number for iodine in potassium iodide. Second, what is the role of this iodine, okay, in the reaction? Okay, so potassium iodide, the oxidation number is -1. Okay, so write down the oxidation number iodine in potassium iodide is -1. Okay, and what is the role? So role over here, you have to say whether it's a reducing agent or an oxidizing agent. So you look at potassium iodide ion becomes I2. So iodide ion becomes I2, -1 over here becomes 0. Okay, so this is a oxidation reaction. So oxidation reaction means it is a reducing agent. Okay, so role of agent. Okay, so you'll get 2 marks over here. 1 mark, 2 mark. Write the half equation for the reduction reaction. Okay, so reduction means it's something got to do with bromine. So Br2 to Br minus. Br2 Br minus have you can see there is additional -2 charge on the right hand side, so balance it out by putting 2 electron. Okay, so you'll get 1 mark. Okay, the next one, photosynthesis process. Based on the chemical equation, state the substance that undergoes oxidation and reduction. Okay, so you have to state first. Then after that, you have to explain your answer in terms of gain of or loss of hydrogen. So just now I told you there are 4 definitions of oxidation and reduction. So very clearly they want in terms of hydrogen. So you have to write down in terms of hydrogen. Okay, so you have to see carbon dioxide. Okay, so carbon dioxide over here becomes C6H12O6. Previously in the reactant there is no hydrogen, and at the product over here there is hydrogen. Okay, so when they gain okay, and then if you look at water and O2, previously there is hydrogen, and after that the product doesn't have hydrogen, so it loses hydrogen. This is the oxidation reaction. Okay, so you have to state the substances first. So you say CO2 undergoes reduction you can straight away continue. It means, so you can get 2 marks. You already state reduction and you already explain why it undergoes reduction. Okay, and then you can say water undergoes oxidation because it okay, so you'll get 4 marks. 2 marks over here, another 2 more marks over here. Okay, question number 2. If a tree absorbs, okay, this one is calculation. If a tree absorbs 270 centimeter cube, 270 centimeter cube of carbon dioxide gas per day, calculate the volume of oxygen release. How much of oxygen is being released over here? Okay, so I write down the calculation over here. So you will have 3 marks. So 3 marks, you need 3 steps. Okay, so calculation over here, you have to follow your number of mole. Okay, you have to follow this diagram. You have mass, you have volume, and you have a number of, okay. So anything that goes inside supposed to be divide, anything that goes outside must be times. So now you are going to convert the volume over here to number of mole. Okay, so you have to check what is the condition given. Is given room condition. Okay, so number of mole of carbon dioxide is equals to 270 24 270 dm cube to, sorry, 270 dm cube, must be the same unit, dm cube to 24 dm cube per mole. Okay, so dm cube cancel off, you will get 11.25 mole. Okay, then the second step, you have to compare the number of mole. Okay, compare the stoichiometry. So you can see there is 6 mole of carbon dioxide and 6 mole of oxygen. So you have to write down 6 mole of carbon dioxide produces 6 mole of oxygen. Okay, so if it's 11.25 mole of carbon dioxide, it is going to be the same. Also produces 11.25 mole of oxygen gas. Okay, so in exam, you don't write like this. You write down in full sentence because this one you'll get another mark. This is where you get your first mark, second mark. And your third mark, once you already know this is 11.25 mole and this one also 11.25 mole, then you can calculate because the question asks for volume of oxygen gas release. Now you're going to convert number of mole to volume. Okay, so volume of oxygen gas released is equals to 11.25 mole times by 24. Okay, so you will get 270 dm cube. Okay, so 11.25 times with 24, 270 dm cube. Okay, because this is mole, this is dm cube per mole. Okay, so mole and mole cancel off, so you get 270 dm cube. Okay, so this will be your third mark. So first mark, second mark, third mark. So mostly if you see calculation, this is how they will ask you and they'll give you 3 marks. Okay. The next question. Question C. Okay, this is the information for 2 sets of experiments, set 1 and also set 2. So you have mixture of metal P and copper 2 oxide. Okay, mixture of copper and oxide of Q. Okay, and you heat it up. The mixture burns brightly, the mixture glows dimly. So by looking at the observation over here, you already know which one is more reactive and which one is less reactive. So burns brightly means you have 2 metals over here. So if you refer to reactivity series, you have metal P and copper oxide. Okay, so if burns brightly means in the reactivity series they are far away from each other. Glows dimly means that means in the reactivity series they are quite closer to each other. This is what you're supposed to know. The distance is not much of a difference. Okay, they are quite close. So suggest metal P and also metal Q. Okay, so you have to find a metal which is far away from copper. So far away from copper, so metal P I can say magnesium. Okay, so you can refer in a reactivity series. Okay, you can give magnesium. Okay, and then if you see for Q, if you see something which is closer to copper, so closer to copper, you can give, for example, silver. So metal Q will be silver. Okay, so of course metal Q means must be at the bottom of copper. Okay, because mixture of copper and um, oxide of Q. That means copper over here will react with oxide of Q. Okay, to form CuO plus Q. That means this one must be less reactive than copper. So I can choose silver. Okay. And then on the left hand side, this one will be metal P plus CuO copper. So of course this one must be more reactive than copper, but far away from copper. So you can choose magnesium, aluminium. Okay. So you will get 2 marks over here for the suggestion. Okay, the next one, explain the observation for set 1 and set 2. Your explanation should include the substance that is oxidized, change in the oxidation number of copper. Okay, so you see you have already given 2 marks is gone over here. So left 8 marks on the second part. Okay, left 8 marks for the second part. So substance that is being oxidized. Okay, so you have 2 sets over here. So you have to explain for both sets. So explain for set 1 first. Okay, so set 1. So what happens in set 1? So I can replace P with magnesium. Magnesium plus CuO. Okay, so you have to again magnesium is more reactive. Okay, so magnesium. So you have to use the word more reactive. Like I mentioned to you just now, if reactivity series, you have to mention the word more reactive, not more electropositive. Okay, more reactive than copper. Magnesium can replace the copper. Write in full sentence, spell out copper from its oxide to form copper. So this is point number 1. This is point number 2. So point number 3, when this happens, magnesium undergoes oxidation. So if you see, I didn't connect, and this is my second sentence, full stop. This is my third sentence, full stop. Don't connect the sentence. If you connect the sentence and if they find contradict answer on your first part and the second part, you will lose all the marks. Okay. So let's say I put over here magnesium undergoes oxidation, you will still get 2 marks from the top answer over here. Okay. And then point number 4, you talk about the oxidation number. So oxidation number change always from initial to the final, change from 0 to positive 2. Okay, so that is for set 1. So you do the same explanation for set 2. Okay, same explanation for set 2. Okay, so you follow the first one. Which one is more reactive? Over here, copper is more reactive. Okay, so point number 1, write down. Copper is more reactive than silver. And then follow point number 2. Copper can displace silver from its oxide to form silver. Okay, point number 3. Copper undergoes oxidation. Point number 4. Oxidation number change from same 0 to positive 2. Okay, so all together you have 8 points. Set 1 4 points, set 2 4 points. So you'll get 8 marks. So don't simply blabber your answer. Make sure you hit the point correctly. Okay. Okay, the next question. So I think this is the last question. I couldn't go into the MRSM question, but you can go through the MRSM question. If you all don't have, then you can always send me message to Telegram. Okay, then we can I can send you the paper and also the answer scheme. Okay, it is available, so you can go through the papers. Very important. Try out the trial paper, especially this one. Okay, it's important. Okay, so diagram 2 shows a conversation between two students about observation at anode after electrolysis of sodium chloride solution has been carried out by each of them. Okay, so if you do an electrolysis and then you have sodium. So if it is a sodium chloride solution, so the ion present should be Na positive, OH minus. Okay, so I electrolyte dilute sodium chloride solution. Okay, so dilute it, this will be the positive terminal, this will be the negative terminal according to the batteries over here. So what happens at the positive terminal is the loss of electron. Okay, loss of electron, oxidation. Oxidation means it's supposed to be anode. And this one, gain electron, supposed to be cathode. Okay, so who will move to the positive electron if you use dilute solution? Cl minus and OH. OH minus ion will be selectively discharged. At discharge, you refer to ECS. Okay, so this is student number 1. Student number 2, I use concentrated sodium chloride solution. Concentrated sodium solution, you still have all these ions. Okay, so if it's concentrated, it will affect the anion. Instead of OH minus ion, it will produce Cl minus ion, and over here the result will be the same. H positive will be selectively discharged. Okay, so cancel off the one not required. So you can see I electrolyte dilute sodium chloride solution and found that the gas released at anode ignites the glowing wooden splinter. So at anode, OH minus ion. So OH minus ion over here will produce oxygen gas, which will ignite the glowing wooden splinter. Okay, and then when I use concentrated concentrated sodium chloride solution, the gas released at the anode turns moist blue liquid paper to red and then bleach. Definitely, it is chlorine gas. Okay, so they have different observation. Based on the above situation, plan a laboratory experiment to investigate the effect of concentration of sodium chloride on the product formed at the anode during the electrolysis. So you need to have your problem statement, variables, hypothesis, and so on. Okay, so what is the problem statement over here? So you have to connect the MV and also the DV. So from the question, like I have taught you previously, you can identify what is the MV, manipulated variable. Okay, so manipulated variable is the concentration of the sodium chloride. So effect of concentration of sodium chloride, and then this is your responding variable. What is the product formed at the anode? So how do you form your problem statement? So you can write down does different concentration of sodium chloride solution affect the product at anode, specifically at anode, and most importantly, put a question mark. Okay, done. Now move to the variables. Okay, so variables, manipulated variables. So I write down over here, manipulated variable will be the concentration of the sodium chloride solution. So if you see all this, the answer already given in the question. It's just that you need to identify. Okay, and responding variable will be the product form. So what variable? If you see, you can fix the solution. That means you use a sodium chloride solution. Sodium chloride solution. I'm going to put in carbon electrode only. Okay, or type of electrode. So variables. Hypothesis. Okay, so hypothesis, you have to relate the variables again, manipulated variable and responding variable. Okay, so you can say if concentrated sodium chloride solution is used, what will be produced? So you can say chlorine gas is produced. At not and NaCl solution is used. So if you use dilute, oxygen gas will be produced. At anode. Okay, so this is also something got to do variables can be answered. Now list of materials and apparatus. Okay, so list of materials, definitely you need to have a concentrated sodium chloride solution. Okay, I will write down materials. I write down here materials. Okay, number one, concentrated NaCl solution. So concentrated NaCl solution, or you can write down 1.0 mole per dm cube. Then the second one will be dilute NaCl solution of, for example, 0.001 mole per dm cube of the solution. Okay. And then the third one for you to check the gas, wooden splinter. Okay. So everything is already in the question again. And the fourth one is the blue litmus paper. Okay. Apparatus. For this setup over here, what do you need? You need battery, and then you need connecting wire, and then you need test tube, beaker, not test tube, you need beaker, and then you need a carbon electrode. Okay, to set this up. Okay, then your procedure for the experiment. So you have to give either, the least is six steps. Okay, so what you have to do first, fill the electrolytic cell. Okay, fill the electrolytic cell with, what is the bahan? So remember, if I mentioned to you, okay, you need to put arahan, then you have to put in bahan. Okay, so fill is the arahan. Fill the electrolytic cell with concentrated sodium chloride solution, half full. Okay, because you have to put in the electrolyte. Then second step, so concentrated sodium chloride solution until half full. And then you have to connect the electrodes to the battery using connecting wire. Okay. Connect the electrode to the battery using connecting wire. And then number 3. Okay, number 3, complete the circuit. Okay, actually the gas is being released at the anode. Okay, so how you need to collect the gas? You need a test tube actually. Okay, so you need additional test tube over here. So you have to put in the test tube, inverted test tube. Okay, so that the gas produced over here can be collected. Okay, so you have to add one more step over here. Okay, so this will be your third step. This will be your third step. So your second step, write down over here, invert arahan first. Invert a test tube. Okay, fill with sodium chloride concentrated. Concentrated sodium chloride solution. Okay, on the anode. On the anode. So it's supposed to be like this, so that you can collect the gas. Okay. And then number 3, number 4. Number 4, complete the circuit. okay, by connecting the wire. Number 5, collect the gas at anode. Number 6, record the observation. Number 7, repeat. Okay, repeat step 1 to 6 using dilute NaCl solution. Okay, it's getting messy. Okay, so these are the 7 steps that you have to put in. Okay, additionally, because the gas produced at the anode, you need to collect the gas, you have to put in an inverted test tube. Okay, then the last one is tabulation of data, F. So based on your variables, you put in the tabulation of data. So draw a table so you know your manipulated variable is the concentration of NaCl solution. So you can write down over here, concentration of NaCl solution. Okay, so it is in mole per dm cube. Okay, then you can give 1.0, or you just now, if you have mentioned concentrated, means you write down over here, concentrated, and over here is dilute. So if you use value just now, 1.0 or 0.01, then you put in the value into the table. Okay, and then the next one is the observation at anode. Okay, so observation at the anode, you just leave it empty. Okay, leave it empty, and that's it. You have written down all the 6 answer for the 6 question over here. So this is SBP paper. So I tak sempat want to go to MRSM paper. So try to do MRSM paper also. And you have any question, you can get back to me. Okay, I'll stop the presentation over here. Got any question?
You may ask any questions we have. Just now in the main room, many of them left, Ma.
Oh.
I think no sound.
No sound.
The main room.
And then did they
I don't know why they left. I don't know why they left. Left in room.
Oh. Okay.
It's okay. Okay. Thank you very much, Shanila. Students, you may ask any question you want to ask.
Okay.
For your last class, this is the last class for you.
Okay, teacher, the drawing can get marked for essay and paper 3. Essay and paper 3. You cannot get full mark, but if you can't answer anything, okay, the best thing you can give out you can give the drawing. Okay, but they want explanation, they want the procedure. Okay, anything else?
Yes, students, you may ask any question.
If you need anything, I can conduct one more class. You can give me suggestion. Teacher, the sentence must use linkers or just write one by one in essay. Write one by one. Don't use linkers.
When is the class? When is the exam, Nila?
9 March.
Oh, 9 March. So upon the student's request, maybe you can respond in the Telegram group.
Okay. Teacher, for the graph, do we have to plot all the points or draw a straight line? In paper, to plot, if plotting the graph, of course, you need to plot all the points. Okay. You cannot simply draw a straight line. If plotting a graph, if sketching a graph, then you can sketch without plotting the points. But plot a graph means you have to plot all the points. Okay, no question.
Students can review this class back in YouTube also. The class is recorded in YouTube.
Teacher, write more than one answer for structure if we're not sure the answer can. Can, but don't use linkers. Okay, but try not to use additional answer. If you are sure with the answer, don't put in additional answer. Okay, if you put in additional answer, then you might lose mark. Okay, if it's contradicts.
Oh no, ma.
Okay, got no question? Oh, the decimal must be 2 or 1. It depends. It depends on the instrument. If let's say they ask the burette reading, it's supposed to be 2 decimal place. If it's a measuring cylinder, then there's no decimal place. It depends on the instrument.
So students, if you don't have questions, maybe Chekmila, still got question.
Okay. Teacher, for example, titration method. Okay, HCl is a strong acid. Okay, 25 centimeter cube, and your concentration is 0.1 mole per dm cube, is replaced with ethanoic acid. Ethanoic acid is a weak acid. What is the prediction of the volume of ethanoic acid needed? It's supposed to be less than 25 centimeter cube. Okay, because HCl is a strong acid, it dissociates completely. Okay, so the H positive produce, if let's say 0.1 mole means it will produce 0.1 mole of H positive ion. But ethanoic acid is not like that. You put in 0.1 mole per dm cube, it doesn't produce 0.1 mole per dm cube. So prediction, maybe you can say 5 centimeter cube. Sorry, you need more. Okay, so you need more of volume ethanoic acid. Okay, so you can put more than 25. More than 25. So must be higher. You can write both. It depends on the experiment. Like for the experiment we saw just now, we cannot use higher. Okay. Okay, welcome.
So Nila, shall we?
Yeah, okay.
Anything else, Ma?
No, nothing else.
Okay, Ma.
Mm-hmm.
Okay, students. So thank you very much to Dr. Nilavati. She's really helping you all and helping us for these classes all the way. If you request in your Telegram group, maybe she will conduct another one more class for you all. If you need the class, okay? Please request. If you need any questions, please post in the Telegram group. Okay, so thank you very much, Dr. Nila, and thank you very much, students, and all the best to you all for the exam. Thank you very much.
Okay.
Nila, anything else, Ma, you want to say?
No. If they need anything, they can always request. I can conduct one more class.
Okay, Ma.
Okay.
If one more class means when you can conduct, Ma?
Tomorrow night. Yeah.
Time, maybe I'll post the announcement, Ma.
Mm-hmm.
Okay.
Okay.
Okay, thank you, Ma.
Okay.
Thank you.
Okay,
Okay,
welcome.
students. Okay, maybe we see you all tomorrow again for your final revision. Go relax and do your revision well. Thank you. Thank you, teacher.
Okay. Okay. Bye.
Bye.